Hello, all, and thank you so much for joining me today on BIMXP. My name is Dana Filippi, coming to you from my home office in Virginia. For those of you that do not know me, I'm a computational designer, Smith Group, and of course, an active participant in a few BIM related groups, including this one, of course, BIMXT, my own YouTube channel, Dynamo BIM. Allison or Emily, somebody's going to send over the link via chat to our mural. You guys can see I already have that up. So if you guys could join me over there, that would be fantastic. Today, we're talking about generative design and AI. But you can see that the area is broken up into a few different areas here. Over on the left, we have a bunch of information regarding BIMXT. You can see you can actually get to our survey. So if you have any information regarding presentations that you'd like to see, um, feedback about presentations that you've already seen, etc., or maybe you'd like to present yourself, please give us some information at that survey. You can see that 5 Revit user groups across the East Coast have come together to bring you the VimXT network. This network is run by a board of advisors to help guide the meetings. And our hope is to provide a live forum for people to share and connect on process and tools relating to building modeling, of course. As a side note, these meetings are recorded and provided online. You can actually see, zoom out all the way to the right, we actually have an area specifically to all of those recordings. You can see that you can get to all of those links to the previous recordings from our past meetings. And of course, all of them are labeled there with what the topic was. The center of the mural is specifically for you. You can see a few of us have already started to add in where we're calling from. I can do that as well. You can see I'm going to just grab the IT, BIM IT related little tag there. You can see the different ones relating to your discipline. We kind of have a legend over here on our left. So I can just copy this guy, paste him, and say, I'm Dana coming from Virginia. You guys are always so orderly about this, and I love it so much. So please let us know where you're calling from. You can see we do have a winner from last time, Mike from Columbia. Congratulations. Somebody will reach out to you if you're on the call. Welcome back and congratulations. Now, today we have some wonderful presenters. On that note, let me get over back to this left-hand bottom corner. You can see that we have Dan presenting our tip of the month today. And then we have 2 presenters, Kat with Hypar. She's going to talk about simple, intelligent space planning with Hypar. Hopefully you guys know about Hypar. If not, you're going to learn all about it. And then we have Aaron with Augmenta. He's going to be talking about accelerating VDC using AI. Now, if you have any questions for any of our presenters as we go through, you can see down in the center bottom here that we have an area specific for questions. So you can go ahead and throw them in there. And of course, our presenters will be going through and answering those. We may even answer them live if we have time. Now, let me check here. Do we have Dan with us? Has Dan? Yes. Dan, how are you? Can you hear me? Hopefully you can. Oh no, he can't unmute. Can you make him a host? Somebody, Kelly or Emily. That would be fantastic. And as we're waiting, please make sure you're adding in your location, your name and location, any comments or questions that you have about generative design or AI. We would love those in the center.
Hey, there I am.
There you are. Usually our team's pretty quick. How's it going,
Yeah,
Dan?
I'm great. Thanks. Sorry, I coming in like hot from a presentation. I was presenting on
We
Autodesk
appreciate
Build
you.
just
We
before that.
we
But
appreciate you being just jumping from one to the next.
I love it. I love it. So, I wanted to put together a recap of Autodesk University 2024, but like there's been 1,000 of those, so I decided to do mine just a little bit differently. And just a quick note, everything you hear and see in this is my personal opinion, does not reflect the opinion of my company, any of my supervisors, Autodesk, or anyone of us standing significance.
We love the safeguards.
But we are going to go ahead and dive into it. So this is Autodesk University, just a quick recap. And you'll learn real quick what I'm doing is a little bit different than what most people are doing for their AU recaps. So first off, let's start with the location. Where was Autodesk University? It was in San Diego, which means obviously a great place to host Autodesk University. If you were there, you'll know that the weather was absolutely great. Personally, I would go to San Diego 100 times more before I went back to Vegas, but I thought it was awesome that Autodesk moved AU out of Vegas to try another location. Next year, AU is going to be in Nashville. So if you're on the East Coast, it's going to be a bit easier to get to. So I recommend checking it out because location is a huge part of the AU experience. Next, if you've never been to AU, it's a lot. There's parties, there's classes, there's networking, there's community events, there's big announcements from Autodesk University. And this is just a quick collage of all the photos that I took, not all, but some of the photos I took. And like obviously
Dan,
far and away.
are you sharing?
Am I
Sorry,
not sharing?
I
I
don't
thought I was
see.
sharing.
Maybe I'm missing it.
No,
I
I
don't
should
think
be
so.
sharing. Do you see it now?
Luckily, we didn't need to know really any imagery before then. You know, San Diego
Yeah.
and
Yeah.
Nashville, we know where those places are, you know.
Awesome.
Yes, we
So
see
can
it.
you
We got
see
it.
now you can see my collage. Okay. Um, yes, so lots of activity going on, and I have read tons and tons of AU recaps, and there's no way that one person can cover everything that's going on at AU, and it's simply because there's just so much going on. So, what I wanted to focus on first were the major announcements that stood out to me, and why they're kind of important. The first one being Autodesk AI. So Autodesk is releasing their new AI module, which will, in the future state, be able to leverage the data you put on Autodesk Construction Cloud to facilitate semantic conversations with your project. The growing relationship between Esri and Autodesk, which is now really starting to play huge impacts on the sort of environment that we exist in with Autodesk. Content catalog is now like out and about. It's publicly announced to formally unify. It is, as of this morning, broken. They pushed an update, which is always fun. Workshop XR is now available for everybody. So that was formerly the Wild, but that is now available to anybody as an Autodesk client. There is now ACC for government. The big piece of this is that Autodesk has officially earned their FedRAMP certification. So they now have a FedRAMP certified Autodesk Construction Cloud platform. And then they're working on and releasing the carbon calculators for Autodesk Forma, which brings those carbon calculations forward in the design process. Big step forward as far as like the sustainability. By the way, all of these are links, and I will show you at the end of this presentation how you can access all of my data and my resource here. So let's talk about the big themes. So there's three main themes that stood out to me. There was the artificial intelligence, the convergence of BIM and GIS, and sustainability. Really quickly, instead of giving you a rundown of these, I want to point you to some classes I think that really highlighted these. So the first one is the artificial intelligence with Bernini. So Bernini is Autodesk's experimental AI tool. It basically takes 2D images and converts them into 3D model objects. It's pretty whiz bang awesome. But that is Autodesk's step forward into the generative AI ecosystem. And then as far as specific classes, there is this class, AI and machine learning are not ChatGPT, a brief explanation of the levels of AI and machine learning and their uses. It's a heck of a title, but the reason why this is an awesome class is Peter explains what the difference between machine learning and artificial intelligence are and how they can actually be used in the AEC space. This is a great primer if you're newer to AI or the whole like artificial intelligence world. And it kind of breaks everything down nice and easy for simple people like me to understand. The next class under the AI sort of theme is Design Smarter, Not Harder, AI-driven comparison and optimization with large language models and Autodesk Forma. In this presentation, the team cover how AI revolutionized design optimization. So they were able to tie a large language model to their Autodesk Construction Cloud ecosystem, and then leverage that data in Forma. It gets pretty heavy, but this is really awesome if you're trying to look at how you can integrate large language models and artificial intelligence into your ACC data. This presentation by Dennis Joff, Artificial Intern, is all about automating design tasks using AI. So the whole concept of this presentation is you can basically automate parts of your design, either generative or procedural based on your project data. And then they showcase some of the special tools that ZGF created, which is actually really neat. So if you want to ask code questions while you're working in Revit, you can absolutely do that. The next major theme is BIM and GIS. So again, BIM and GIS are sort of converging. If you're like me and you have a dangerous understanding of what GIS is, it's basically like BIM, but it's everything outside the building footprint. And these two worlds are coming closer and closer together. And this has been a growing theme in all the AUs I've been to so far. First class I want to point you to is automating design workflows using ArcGIS machine learning tools and aerial location intelligence. This is an absolutely fascinating class where Kimberly Horn took information from Esri and was able to use the machine learning visual tools to start doing quantifications from objects on site. So they were doing takeoffs of all the parking spaces on an existing parking facility. And all that information feeds forward into their actual design information. So they had really robust GIS and concrete project data going into design. The next one is breaking down barriers, a BIM to GIS workflow. Again, this one's pretty heavy-handed, but what this presentation goes through is how this team integrated their Esri ecosystem into the Autodesk ecosystem. And that facilitates a lot of their design workflows. And by bringing together the Esri ecosystem and the Autodesk ecosystem, their civil teams are better able to coordinate with their design and build teams. The final third theme is sustainability. This one comes up over and over again, but Autodesk is making some big strides. There's two classes in here I want to highlight. The first one is digital considerations for a circular future. This is arguably the most beautifully composed AU class I've ever seen, just simply because the graphics are so good. But Sam Sweeney from 3XN, GXN showcases how they use digital tools like Rhino Inside, Beam, and Speckle to enhance their Revit workflows, which gives them stronger understanding of the carbon cost, the physical materials, and things like that. It's really hard to summarize this presentation in a single sentence, but they go soup to nuts on how by bringing together all these different tools, how they have a robust 360 design ecosystem. And then finally is sustainability and sort of AI in Forma, leveraging Autodesk Forma to expand the understanding of context and development. In this presentation, the team goes through how they use Forma to establish like design options, how they use those design options to then understand design impacts and like how that impacts downstream quantities. And then they also use this information for like microclimate adjustments, and it allows the design team to continue to think about sustainability much earlier in the design process, when they're literally just pushing and pulling blocks and they're trying to understand how's that going to impact my groundwater runoff and my environmental ecosystem. I like this so much I put the slide in there twice apparently. And that is my recap of AU and the major themes and all the classes you should consider going and visiting. I'm going to leave this QR code up here while I stall for just a little bit. This will download it from my Google Drive, and you are welcome to have it. If there's anything else you want to chat about, please feel free to reach out to me. And with that, I'm going to turn it over to Dana.
Well, Dan, as someone who is not at AU, thank you so much for the recap. That was very enlightening. And I will put the QR code in the mural, which if you have not already, please join us over there. Before I jump over to our first presenter, I'm going to come back into our mural. You can see Many of us have already added our name and location up here at the top center. Thank you so much for doing that. And I love the one that's slightly askew. Us BIM folk are very orderly. We're very fond of that. Now, before I jump over, I will say that many of these images that you see here are actually links. So you can see over on the right, for example, if you wanted to go and see the January meeting on design fabrication, you can actually open that by getting it double clicking or clicking on that button down at the bottom right. It says open link. You can also see that you can get to our survey as well as all of our advisors and their information as well. And maybe, Dan, you can even create a link to the QR code. I'm not sure whether you can do that with our permission level, but you should be able to. But you can, of course, use the QR code as well, right? Now, without further ado, I'm going to stop sharing here and pass it over to Kat. How's it going, Kat?
Really good. Thanks, Dana, for having me on this session. And thanks, Dan, for doing a recap. I wasn't at AU and I'm sad because I did see there was some sort of therapy puppies or something
I
top
believe
left
that's
corner.
every AU. They have dogs. So next year
Uh,
they will probably have them as well. So hopefully you'll be able to join. I hopefully will be able to in Nashville.
Great. So I can start. So let me do the age-old sharing of the screen. And what we'll do today is I'll talk a little bit about Hypar. I'll do a video demo of a complete workflow, and then I'll also open it up to a live demo. So I caveat, I think good software should always stand the test of a live demo. So I really am a big fan of building in public. I'm a big fan in kind of showing all our cards. And so a caveat that this will be a live demo. So let's start first with a little bit of what we're doing. So I'll go ahead and share my desktop. Yeah, let's start. My name is Kat. I'm a product manager here at Hypar. Anthony is also on this call, and we're really happy to be here. So, a little bit about Hypar and our vision. We have the vision to deliver the world's building expertise available to everyone instantly. And that's a pretty lofty vision. So, when we go down to the specific use case and the specific problem we're trying to address, at least initially, at least today, is this idea of turning complex program requirements into accurate plans and doing that with precision, speed, and ease. And of course, I'm going to use a Lego analogy. I wouldn't be an architect if I didn't use some form of Lego analogy, but it really does hold truth. We have a number of users, a number of people we've spoken to over the past few years, hundreds, in fact, and they're trying to essentially do this sort of space planning activity. Space planning is sort of one of the early phase activities that one does. It's very common in healthcare. Of course, it's also very common in workplace and other sectors, labs, for example. And really, people want to be space planning quickly, efficiently, and they kind of want to use their cubes or the things they've made that are standard block sizes, things that have the specific areas. They want to use those really quickly and they want to use those as Legos, but often they're not able to do that. Often they resort to things like using Bluebeam, which is great to a certain degree, but then they have to redraw and it's also in 2D, so their clients can't really understand it. Then they use things like SketchUp, which doesn't really translate very well to Revit. And of course, they've created solutions in Revit. So we've seen a number of people create these jelly cubes. You may actually have created some of these jelly cubes, and they're fantastic, but they're also fiddly, and you're doing kind of the best you can with what you have. So we've started to develop a software and a solution to address this challenge with the engine that we built over the past 4 or 5 years. And so I want to talk a little bit and talk a story and kind of give a story about Yana, who is part of Slam. And so Yana is a healthcare planner. She's part of Slam's healthcare group. And one of the things that Slam gets are these very specific standards from clients. So they get very specific standards. They sometimes even get 3D models in Revit from clients that are very detailed. And so they want to be able to move those around with speed and ease to create these proposals, because they're not getting paid that much to do this sort of proposal planning stuff right off the bat. So they want to be able to do that very quickly. In addition, some people don't go into Revit. Not everyone is well versed in Revit. So you have some of the more senior planners or some of the more junior planners really looking to find a solution that's maybe a little bit different than Revit. So first time she was playing with Revit, Hypar, she was blown away by the arsenal of tools. And she was really able to manipulate models very quickly before her eyes using her client standards. So using her content, using her furniture and equipment right in Hypar as the thing it is, and then exporting it back into Revit without missing a beat. So that's something that she found was very popular and very, very useful for her. And our second person, or second company that we've worked with is a fellow named Alex from Revise. And Revise is a 5-person firm. And they are a small firm in Boston, and they're really trying to leverage their small team to create these office test fits. So in Yana's case, super standard, lots of complicated things. They created their own chiclets. They didn't really work that well. But in Alex's case, he's doing these quick office test fits, and he has to kind of give those test fits to a client in a matter of days. And a lot of the time, they're not paid that much or at all for these test fits, because they're waiting for the client to sign a lease and so forth. So he was able to lay out 100,000 square feet across 3 floors in about an hour, which is incredibly fast. And Alex is like a very proficient Revit user. So the fact that he was able to do this right off the bat without that much training is really indicative of the sort of work we were doing. And it's a killer tool, and more people should use it. So not only is Alex able to use it, he's able to train people and his team to use it and really leverage it and start to scale up his team to create these very quick office test fit proposals. So that's a little bit about the use cases, and there are a number of people that are using Hypar. And the very first thing I want to kind of mention when it comes to Hypar is you can just start. I think there's kind of this belief that you should get training, or there's a belief that you should have someone set it up for you in IT. There's very little to set up. You can just start. You can just go on to hypar.io and just play around. You don't even need a program, although we do ingest programs, and I'll talk about that a little bit more. But you can just start, and it's really straightforward. There's kind of a saying that some of the most powerful things, or some of the most profound things, start out looking like toys. And this is kind of where we're thinking about, where this is a very pared back, very simplified UI, but lurking behind that UI is just an engine that is incredibly powerful. So one of the things that we're trying to do is let people be able to just start. So by the time you open up Revit, you could already been planning in Hypar, and you could have already created a plan. So you'll see that we have our kind of different tools at the bottom toolbar, and you can just add a space. You can manipulate that space. You can change the square footage of that space. Obviously, this is in feet. You can do it in meters. You can add more spaces. You can snap to those spaces. You'll notice that we do a tremendous amount of work behind the scenes to make all of this super seamless and easy to use. So we do have the snapping infrastructure. We do have some of this stuff. And when we say that this is all kind of automation, it's this sort of automation. It's automation that is less in your face and more kind of holding your hand. So you can see things like you can plan with blocks. You can plan with a grid. We've noticed that people in lab spaces love to do modular grid planning. So we added a grid. You can put in your PDF, you can put in an image, you can put in a DXF, and we're working on you being able to put in your own Revit models and adjust them. But that's really the gist of it. So behind all of this is just an incredible engine and kind of an infrastructure to be able to do all of this seamlessly. And one of the things we do that maybe Revit doesn't necessarily do, or not really that easily, is this idea of tracking your progress and tracking your program. So you have this task of turning this complex program into space, into jelly cubes. And of course, they don't have to be cubes, but you can add in your Excel program. And Hypar will take any type of Excel program. You don't have to fiddle with a specific template or format. It will start to ingest most programs. And what you're seeing me doing here is actually adding different properties that it perhaps didn't initially see. So everything in green is something that Hypar has already recognized as a piece of data that it wants to ingest. And of course, I'm adding cost per square foot, which is kind of a way you can, in real time, measure quickly what your cost per square foot could be. So I'll go ahead and import all of these. And what I'm creating here is actually a little bit of a birthing center. I am not a medical planner. So just caveat, my previous life has been on workplace and kind of R&D. So I've tried my best to lay out a medical center or a birthing center, but you'll notice that I'm adding kind of department and I'm adding program name. And you'll see as this goes through how this all is brought up into Hypar. And on the right side, you'll notice that we're starting to basically track what you have. And you can change your requirements, of course, on the fly, and you can do a bunch of things. And you can also change what you need. So now let's plan at multiple levels of detail. So one of the things that you can do, and one of the things we've heard a lot of our users ask for, is the ability to plan at the departmental level, but then actually go into that department and plan at the room level, the ability to hide, show furniture, the ability to basically switch between levels of detail. And so we were able to do that. And one of the things we can do here is I'm going to go ahead and select all of these and just kind of lay them out. I'll turn off the walls. They come out with walls, but you can easily turn those off. And I'll start to just lay out spaces and see what sort of adjacencies I want, what sort of spacing I want. Of course, this is kind of more greenfield, but you can always do that with an existing plan or with an existing context. I'll go ahead and add another NICU and start to do some of this work. And you'll notice there's a lot of affordances that we're allowing people to do, with whether that's constraining areas or letting folks edit their shapes really, really quickly, and do these sort of snapping exercises. We did a number of tests over the past year or so to basically make sure that this interface and this program is incredibly easy to use, but yet still super precise. So you'll notice me just kind of adjusting things as I go. And I might want to do this, which is essentially enable a diagram or more diagrammatic mode. Sometimes you don't want to show walls, or you don't even want to show the corners of things to your clients. So of course you can switch, and it's kind of that level of detail that I'm talking about. So I'll go ahead and do that, and I kind of always switch back. So, and now one of the things that I'm able to do is to bring in different pieces of room level program and room level requirements and put it into this department. So now the department acts as a container for all that information. And you can move the whole department, you can move the rooms within the department, you can copy them, you can flip them, you can do all this. I'm doing this in 2D, but of course you can do this in 3D. And you know, a lot of these things I'm kind of showing as hand wavy, but some of this stuff is really quite tough to do. Like, you know, making sure that all the rooms adjust correctly with the spacing on the walls when you change it all in one go. All of that stuff is actually really, really tough to do in other programs. And there's a level of finickiness and fiddliness that Hypar just doesn't have. So that's kind of a cool challenge that we had to work with, is how do we create something that is super easy to use and can be used quickly and kind of a little bit like messily without losing that level of precision. So there's quite a bit of work that went into snaps and quite a bit of work to get it to this level. And it's hard to see this in a demo. Really, it's best to see it just using the software. And you'll notice that one of the key indicators, and one of the things we really pride ourselves on is, does the user have a joyful experience? Is the user happy? Is this user enjoying the thing they're doing? Because a lot of time we get these conversations with users where they go into architecture, they go into design, and then they're stuck using these tools that are kind of like soul sucking in many ways. So one of the things that we're trying to do is to make those tools less bad. So you'll notice that I'm doing some of this work. And of course, it's tracking. So right now, your patient room is 180 over 180. So I haven't changed the dimensions of it. But you'll notice that sometimes I might change dimensions, and I really want to show the user like quickly how you're changing those. So let me go ahead and start to change the dimensions of this nurse station. And you'll notice that the actuals are different than the program, and you get that kind of quick feedback really fast, and you're able to make decisions really quickly. You're able to show your colleagues really quickly. You're even able to show your clients. So that's kind of the gist of it. And of course, you can always go back to diagram mode. We actually have seen people use diagram mode while they're planning, which is really interesting. Now, one of the things we've just recently announced, and this was actually just yesterday, is that our interoperability with Revit. So before, you could bring in your model from Hypar into Revit, including walls and rooms, and so you wouldn't have to build something from scratch. And now you're able to actually bring in your furniture, your equipment, and your rooms into Hypar. And what I'm doing here is just grabbing something from Herman Miller. I did not even clean this model up. And let me tell you, there is some very messy stuff from Herman Miller. This one is probably on the better end. And all I did here is just add a room to enclose it. You don't need to add a room, but you can, and it helps. And I'll show you kind of a bit of things we're doing there. So all I did is add a room. I'm going to go ahead and select it. I'm going to go ahead and do an add-in and send selection to Hypar. You can get our add-in. It's free. You can try Hypar. It's free. And so I am obviously speeding this up because I don't want you to sit with me for like 4 or 5 minutes, but I'm not speeding it up as much as you think I am. So you'll see that we're ingesting everything from Revit. We're making it really lightweight. We're making it really easy to manipulate. And we're also retaining all that information. So when you bring it back inevitably into Revit, it will be the same thing you brought in. So no changes there. So we'll go ahead, send to Hypar, no errors, which is great. And then on the top banner, you just click place, and there you go. So all your stuff in Hypar, whatever you need. And all that stuff is manipulable and also intelligent. So we bring in things if it's wall hosted or kind of if it's close to the wall, it becomes wall hosted. So you don't have to fiddle with any kind of anchoring, or we're not allowed to say the word anchoring because it's very jargony, but you don't have to fiddle with anchoring. And it just brings in stuff from Revit and it makes it smarter. So that's kind of the gist of it. And of course, you can manipulate and move things. You can move that stuff outside of the room. You can rotate it. You can copy layouts. You could add more stuff from our own library of stuff that we've given you. So I'm adding a chair here. And you'll notice that, I don't know, it goes really quickly and sometimes it's almost like kind of in the background, but you'll notice that there's these pink snaps that really make all the experience a lot better. And so I'm going ahead and copying the layout to another room that's slightly different. And then we'll talk a little bit about real-time analytics. And this is something that we're really working on right now is how do we make sure that we give the right analytics to people at the right time, and then analytics at the right industry, and making sure that you have all the data you need to make really good decisions. And so you can see that we're starting to pull in this sort of use case. So I've moved away from my birthing center, and now I'm in somewhere where I have a little bit more familiarity, which is the sample workplace. And you'll notice that I am looking at gross floor area, net area, building gross up factor, or kind of this number for efficiency. And as I select different things, you'll notice that I'm looking at data. So the number of desks is a big one for test fits, of course, and all the things that kind of come with it. So we're still working on that just to see, what else we can bring and how we can visualize that a little bit better. And the last bit is kind of sharing how you want to share. Of course, we'd love for you to share live. It is fully collaborative. It is on the cloud. Multiple people can work at it at any given time. However, sometimes we've learned from you that you want to be able to be a little bit more targeted in your presentation, especially to certain clients. And so we want to be able to let you share however you'd like. And in this case, I'm sharing it with this sort of diagram mode. I'm going to go ahead and export it to PDF. You have a little bit of title blocks. You have a scale, kind of all your table stakes stuff that you're expecting it to do. It does. And of course, you have all your tags. So we do this very sophisticated thing in the design part of our app where we bring the labels in and out depending on the zoom, and bring and that helps a lot with design because sometimes you just don't need to see that information. But in a PDF, of course, you want to see all your labels in one place. So we let you do that. And you can go ahead and export a PDF and share that way. You can also share with you can also share by doing different things. So you can, if I go back to that, I'll just kind of quickly do that, is you'll notice that you can go through walk through, and you'll notice that you can go through basically turning different things on and off. So you can turn off all the furniture. You can now go into walkthrough, and that gives you a good sense of we've heard from many clients, especially in healthcare, that they have doctors and nurses that sign off on some of these spaces. And it's only until they see the thing in 3D that they really understand what they're seeing. And so there's this, there's a lot of really good space planning apps that are in 2D that are really great. However, for certain clients, you have to see the thing in 3D. So this is one of the ways you enable people to see these complex spatial relationships really quickly in right in the app. You don't have to go anywhere else. And so, of course, you can put things as editor, viewer. You can invite different people into your software. But wait, where's the AI? So, of course, this presentation was about AI. So I'm going to now move towards the live portion. Please bear with me. This one is going to be a little bit more live. And so we're starting to work on a thing called suggestions. You may have remembered us from these videos, the provocative text to BIM video that we brought in, where we basically hooked up the prompt kind of LLM or natural language kind of interface to Hypar, and that allowed that interface to call different functions within Hypar and bring in a whole model. And of course, that got a lot of publicity. It was very much a demo. But I think as we started to think about AI and generative AI and all the kind of buzzword terms, I'm starting to forget what some of these are, but we started to think about, well, I think people would really want to work and interact not with prompts, not with sliders, but with the model itself. And so what I'm showing here is let's go into our live demo. And so this is the workplace, and I have to caveat that it may not work, but let's go ahead and actually start to build out some of this. So some of this open collaboration and let's say copy resource. Let's do open collaboration. So you'll notice that I can pull up open collaboration, and you'll notice that there's no furniture anywhere in the different in this open collaboration. But you'll notice something that happens on the side here, which is essentially our suggestions. And we're starting this and we're building this out, and suggestions will prioritize your preferences. They'll be ranked. And right now, those suggestions are very much suggestions for furniture. But in the
Well,
future,
and
those
I'll
can be other
say
things.
what I have seen just in the last 5 months since I spoke with Ian, you guys have done so much, so many changes. And I know you guys have so much to share regarding Hypar. Unfortunately, we have to jump over to Aaron. We do have, not unfortunately, but we have to cut you off. Very
Good,
excited for the
good.
presentation Aaron
Yeah,
has, of course.
great.
People are
Well,
so
more
excited,
later.
Kat, that we do have a bunch of questions. So if we do have some extra time at the end, we can of course get to those live. I've tried to add some comments to them so far, but we'll go ahead and jump over to Aaron. How are you doing, Aaron?
Good. And yeah, sorry, Kat. I was actually very engaged. It's really beautifulally executed. So
And I
I'm
know,
sorry that we
Kat,
couldn't
you
go
could
through the full
probably go
demo.
on for another 20 minutes because there's so much Hypar has to offer. So
Just leaving you
absolutely.
on a cliffhanger. Just going to leave it on a cliffhanger.
Exactly. You got it.
Okay. All right. So I'll take it from here then. So thanks again, Dana. Thanks again, Kat, for that awesome demo. So I'm going to talk about something a little bit different. We'll be talking about what we're working on, and that is really the application of generative AI to the problem of design, but sort of a different aspect of design than what we just saw from the Hypar team. So we're really focused on meaningfully transforming really the detailed design process, being able to go from initial concepts, maybe even something very similar to what we just saw, to construction-ready designs in a fraction of the time that it takes today, while also producing much more efficient and cost-effective designs in that process. So I'll cover a couple things today. First, I'll give a bit of a background on why that part of design. Why are we working on this problem, specifically detailed design? Why is this really the most important part of the overall construction process to apply AI to? I'll talk about what we've built so far, how it works. We'll show a case study of that technology applied to the real world. And then I'll finish off with just some really quick thoughts into our roadmap and the ultimate vision that we're working towards. So very, very quick backgrounder on us. So there's myself, there's Francesco, my co-founder. Obviously, there's a whole lot more really talented folks on our team, but a bit about us specifically. So Francesco, our CEO, initiated the generative design program at Autodesk. I worked with him there to figure out the fundamental UX, user experience principles of those types of design systems. We created Augmenta together to apply those ideas to construction. So what we're doing is we are building autonomous agents that automate the design of core engineered systems, like, for example, your MEP system. So those are the things that are behind the drywall that, as many of us know, especially more on the construction side, really drive up the cost and complexity of building projects. And by automating the design of those systems, we can really speed up that overall design process, make the whole thing a lot more efficient, while also enabling the entire industry to build better, more efficient buildings a lot faster and cheaper than before. So in terms of why we're working on this particular problem, so overall, I know most of the folks on the call know this, construction is the second largest industry in the world, probably the one that on a day-to-day basis has the greatest impact on our lives. It accounts for 40% of global carbon emissions. It's a very critical sector. It's tasked with housing a rapidly growing population, not just in the US, but in Canada, where I am too, and in many parts of the world. But it's also an industry that faces a set of critical challenges. So we've all heard this stat. From a productivity perspective, construction has been essentially flatlined for the last 40 to 50 years. Inefficiency and rework is rampant in that process. In the US alone, $65 billion are spent on rework every year. And all this is compounded by a very severe labor shortage. So everyone on this call is being asked to do a lot more with less. Projects are tighter, margins are tighter, there's more and more risk, and there's less and less people to do the work. So where we're focused is the overall design process. We really believe that there's a lot of challenges within construction overall, but the design process is probably one of the most significant levers that we can work on or try to affect or move to help solve those problems. And when we say design, we're not just talking about the architectural process or the engineering process. For us, it's really every core activity that connects the initial requirements and idea that goes into a building down to the actual construction. So that also means estimation, coordination, detailing, spooling, shop drawings, everything that really connects idea to the field. Those are all the fundamental planning of activities that ultimately are most responsible for the actual efficiency, the actual real world, cost and operation and construction time of a building. So today, that design process, what we see here sort of represented abstractly on the screen, is not productive enough to meet the needs of the industry. That's not the fault of anyone involved. A number of us are trying to solve the problem. Hypar is a great example of that. Fundamentally, buildings are just very hard things to design, and they're very hard to optimize. And one of the problems is that they are designed several times over by a number of different parties as requirements change or information is added through that process. And every time that tweak happens, you have a redesign, a change order. That means cost, it means risk, it means uncertainty, but also means that those parties at the very beginning of the process never had really any way of knowing how much their building would actually cost, how it would actually perform, or how long it would take to build until they're very quite far along in that process. So if we could somehow automate the core parts of this design process and do it in a way where all those considerations of constructability are fully considered from the start, if we could push that information upstream, we can really reduce that uncertainty and really reduce the cost and the waste that comes out of it. So starting to get a little bit more specific on what we're doing about this. So our platform uses a combination of machine learning methods. We synthesize construction expertise and then use it to automate key tasks in that design process. And sort of our angle on this, what's unique about our approach is that we're not just automating some of those preliminary design activities. We're not sort of producing higher level designs that then need to be taken or reworked for coordination or constructability, for example, when it gets into the hand of the contractors. We're actually incorporating field expertise from the contractor level to ensure that we only produce fully constructible and actionable designs from the very beginning. So these are designs that you can actually use to procure, you can fabricate, you can send them directly to a cutter or a bender or order off of them and ultimately install them. And so what we're ultimately trying to do is, again, take that certainty that you get at the shop drawing level and find ways to push that upstream to when the most critical design decisions are being made in any given project. And as it turns out, working at this level of detail is very complex. It's quite a hard problem, but we've made significant progress on this over the last couple of years. That's what I'll be showing you today. But fundamentally, we're not attacking this whole problem all at once. Right now, we're really focused on the coordination, routing, and modeling of those core systems. So already we can see that using AI in this application does save a lot of time, significantly reduces errors, and is a lot faster overall than doing it manually. So the first agent that we've built is for electrical engineers and virtual design and construction teams. So those teams inside the electrical subcontractors who are taking the higher level specifications and then building out, routing that conduit, adding the couplings, adding supports, converting that into something that will be acted on in the field. We are automating the routing and coordination of those electrical raceway systems. Like I mentioned before, we're really focused right now on the very start of that modeling and coordination workflow. So we take you from a model with no conduit populated to one that is routed, modeled, clash-free, that you can bring into a coordination meeting or otherwise go and act on. The way it works is it takes a set of data points. I'll expand on this in a couple slides, but it takes in a background Revit model. We can take that model from anywhere. It doesn't have to be Revit, but we need effectively a site model. We need to know what we're routing inside. We need to know what we can support off of, penetrate through, and so on. We take a description of what you're trying to connect together in that model. We have design rules. These are your project specifications. Take all that input, and then in a couple hours, generate a number of designs for you to review that are fully routed and coordinated. So we're using this technology already in the real world. One of the case studies I'll be taking you through, or the case study I'll take you through today, was demonstrating the use of this by CNR Electric in a recent project on an elementary school called Mount Hope Elementary. So here they used our tool to automatically route over 11,000 feet of conduit in about 3 to 4 hours. So that's a really good, I think, example of how using AI this way can really optimize what is today a very complex and tedious task that requires extensive manual effort, ultimately getting you to a faster, more reliable design process. So what I'll do is I'll show you a quick video. I'm going to hop out of the presentation to do that because it'll run a little bit more smoothly. Just give me a second here.
The level of sophistication that we have is miles ahead of anyone that I've heard of doing something, anything like this.
We used ACP to run all of our conduit, and the guys are down here now on site installing all of it. Augmenta is going to be the piece that, instead of spending hundreds of hours drawing conduit down corridors, it's going to generate your paths for you. So it's just the next logical step to get fabrication out the door faster and hopefully more accurately.
Everything that's on these pipes, like the labels and whatnot, the circuits, is all populated and put into place by the ACP.
Oh, wow. It gives us a competitive advantage. We know the entire infrastructure.
It's doing it for you. It's very simple to use.
Okay. All right. So let's go ahead and talk a little bit more about, just skip that. Let's talk a bit about the performance, as in how well does it actually work? That's going to be on everyone's mind for sure. So a bit of framing here. We at Augmenta, really think of ourselves almost like a self-driving car company, and that's actually how we operate ourselves internally. We're not doing self-driving cars, we're doing self-driving BIM, or self-driving design. So our goal and how we measure our progress is we want to reduce the amount of human intervention in the designs our system produces over time. Meaning that as time goes on, a human being can produce more and more design work in the same amount of time. In a self-driving car company, that's your interventions per mile. How many times do I have to go and take over? In our case, it's how many times do I have to go in and make a modification to something that our system produced. We've made really significant progress in the performance of our system, but it's not yet producing perfect design. So here's an example of what that looks like in practice. This was on that CNR project. So what we output is here on the left. What we can see then is that CNR made some changes here, right? So they adjusted the elevation of the rack. They adjusted here some of the layout of these conduits. Later on in the project, they added a few more conduits, so they didn't use our system to regenerate the entire design. We got them 80, 90% of the way there, and then afterwards, we're outputting a generic Revit model, so it's very easy for them to make slight modifications on top of that. And then we can see the final installation there on the right. So today, what we're really doing is we're taking folks to, again, that 80 or 90% stage, and we're measuring our progress in reducing that amount of intervention required so that eventually we'll get to that 100%. So internally, we really measure the performance of our system with this productivity metric. In the last 12 months, we've increased that productivity by 10x. Early this year, around April, we surpassed human productivity. So that was when we got past that 1x threshold. And of course, then we've grown significantly since then. And that rate of increase is growing. So certainly in the next 12 months, we really expect to see very significant improvement. And then, of course, in the future, we'll be moving on beyond just electrical, but I'll talk about that in a second. Okay, so let's talk a bit about how it works. What does it actually look like to use our system? So very quickly, I'll go through this at a high level. The workflow is broken down into 3 steps. So first thing that you're doing is you are inputting that data. I already talked about this a little bit in a previous slide, but essentially you're giving it everything it needs to know or understand about a problem to solve for it. So that means I'm giving it a Revit background or some form of site geometry. It needs to understand what it's coordinating around, what it can support off of, penetrate through, and so on. There's different preferences I might have about, oh, I'd prefer if you ran down this corridor, if there's enough room. I don't want you running through here. So you're marking up a model with this type of input. You're describing the things you want connected. You're describing your project specifications in terms of supporting methods. clearances, things like that. Once you've set all that up, you hit generate. The system will then go and generate a number of designs on your behalf. Each of these designs are costed well, we have a cost and labor evaluations for any design produced. So on its own, it's sort of on your behalf trying to produce a divergent set of solutions. It's trying to show you what are the things that I can choose between on this project. Maybe I want to optimize for the design that costs more but can be built more quickly, or vice versa, depending on the needs of that project. Once those designs are generated, you can export them into Revit. So we're just exporting for now this design as generic Revit conduit. It will look just like something that your own BIM team would have produced themselves. And it's very easy then for them to detail it out, modify it, add their own information to it. But we're really just trying to integrate very seamlessly into the way people work today. All right, so where are we going next? The ultimate vision that we're working towards is a platform that automates multidisciplinary building design. So everything from the MEP systems to the structural systems, even some aspects upstream of that. Really, we want to be delivering optimized construction-ready designs at the click of a button. This is really a fundamental step change or a shift in how we think about the way buildings are designed and constructed. And philosophically, we kind of think of this as a return to the concept of a master builder. It's this return to this sort of mythical time when buildings were designed by individuals or very small teams who intimately understood every aspect of how a building came together. And that's really what we're trying to do here. We want to democratize the process of design at that level so that architects, engineers, contractors can very rapidly design and iterate and ultimately optimize all of these different systems together with full confidence of the constructability, knowing that every nut and bolt consideration of procurement, fabrication, installation is designed every time I even begin to sketch out a building, not 3 or 6 months down the road. So we're approaching this in steps. We're starting off with the design of electrical systems. Next up, or now, we are kicking off the development of mechanical and plumbing systems, and we're not going to be just automating those independently like what I just showed you now, but designing each of those concurrently. So everyone specifies requirements, and we're producing these fully coordinated, fully considered MEP systems where everything is known to fit and can be optimized for higher level project goals. So in summary, what we're really trying to do is build a future where buildings are designed the same way a microchip is designed today. We're aiming to really fundamentally rethink how design and construction works together, how it happens, because we want to be able to help everyone build better, faster, and with a lot more precision and certainty. So we think this is a very interesting problem to be working on and to try and solve. If you find what we're doing interesting, I hope that you'll reach out. Best way to reach us is actually via the email that you see up on the screen here. So that's for our VP of Growth, Matt, who's also on the call. But I'll leave it there and thank you for your time.
Thank you. And since we have a few minutes, Aaron, there are a few questions. How are requirements inputted to the platform, like Excel? And how would you define where the system can run, not run, penetrate, etc.?
Sure. Yeah. So a lot of it comes out of Revit. So just getting into details in Revit, I have my structural, architectural, anything I need to coordinate around is linked into Revit. So that's my starting point. I have my electrical equipment that I have placed, like you as a user have placed. That panel is going to have a panel name. You provide a separate run schedule that simply just describes this panel connects to this junction box and so on. So you're providing all of that information around where your preferences in terms of routing. We have a Revit plugin that you use to mark up the model, and you're basically drawing out different spaces and volumes that have different sort of meaning associated with them. It's a lot more intuitive when you see it, but basically you can just sort of mark up your model in 3D and you're illustrating, okay, this is a preferred space, so we'll try to bias the route through here. This is a keep out, so I don't want to route anything through here unless it's to hit something in this room. So we have a fairly intuitive workflow of being able to mark up that model with those preferences.
Fantastic. And Kat, since we had so many questions there, is there anything that maybe you wanted to wrap up or let the users know before we jump off?
Just start. You can try it. It's free for 3 projects. And I know I've touched upon it being useful for healthcare and workplace, but of course you can use it for a variety of different things. And in fact,
Get
people
the
have
Revit add-in,
hacked
right?
it. Yeah.
It's free. So
Yep.
I've put the links both for Augmenta as well as Hypar in the mural under the left side under the presentation information, so you can get to those very easily. And of course, reach out to Aaron and Kat if you guys have any questions. Thank you guys so much for your presentations
Thank
today. I feel
you.
like you both probably could have filled the whole session today. So thank you so much for giving us with this information.
Okay.
And thank you
Thanks for
all, of
having us.
course, for joining us.